Welcome to the DIY Honda Garage channel. DTC P0100 refers to a problem detected in the mass airflow MAF sensor circuit of the Honda CRV models from 2017 to 2022. The mass sensor plays a crucial role in measuring the amount of air entering the engine, informing the engine control unit, ECU, of the correct air-fuel mixture. If the ECU receives inaccurate readings, it can lead to performance issues such as rough idling and reduced fuel efficiency. This error code indicates that there is a malfunction within the sensor circuit, prompting the need for diagnostic inspection. The location of the MAF sensor is typically along the air intake pathway, either integral to the air filter housing or slightly downstream. When troubleshooting DTC P0100, it's essential to understand this background to ensure accurate diagnostics and repairs. The MAF sensor is responsible for gauging the volume of air entering the engine and is vital for efficient engine operation. This data enables the engine control module, ECM, to adjust the fuel injection accordingly, optimizing performance and emissions. Alongside the MAF sensor, the intake air temperature, IAT sensor, is also critical, as it measures the temperature of the incoming air, providing additional data for the ECM to balance the air-fuel mixture. These sensors are usually situated in the air intake system, typically mounted near the air filter housing. A failure or malfunction in these sensors can lead to poor engine performance, increased emissions, and reduced fuel efficiency, making timely diagnostics essential. There are several potential causes for DTC P0100. Firstly, poor electrical connections or corrosion can impede the flow of signals between the MAF sensor, the IAT sensor, and the engine control module, ECM. This could be due to loose wiring or pin fitment issues. Secondly, there might be shorted or open circuits in the wiring, which can disrupt accurate data transmission. Additionally, a malfunctioning MAF sensor or IAT sensor could directly cause this error code by providing incorrect readings. Lastly, environmental factors like dirt or debris infiltrating these components could also impact functionality, thereby triggering this diagnostic trouble code. Thorough inspection and testing are necessary to isolate the exact cause to effect the appropriate repair. When DTC P0100 is present, you may notice several symptoms affecting your vehicle's performance. One of the most common symptoms is a rough engine idle, which can lead to an uncomfortable driving experience. Drivers may also observe poor acceleration as the engine struggles to receive the correct air-fuel mixture for optimal performance. Furthermore, increased emissions are a significant concern, as inaccurate readings from the MAF and IAT sensors can lead to an inefficient combustion process, resulting in higher pollutant levels. Other related indications may include a decrease in overall fuel efficiency and unusual engine noises, making it vital to address this DTC promptly to restore vehicle performance and compliance with emissions standards. In the first step of troubleshooting for DTC P0100, start by turning the ignition switch to the on position without starting the engine. This action allows the vehicle's systems to enter a diagnostic state and prepares them for monitoring. Next, utilize the Honda Diagnostic System, HDS, to clear the diagnostic trouble code from the system memory, which resets the error status. After this, it is crucial to wait for 2 seconds or more to give the onboard systems adequate time to reset and recalibrate. Finally, after waiting, check for any pending or confirmed DTCs using the HDS. If DTC P0100 appears again, it confirms that the malfunction still exists, allowing you to proceed with further diagnosis. Proceeding to the second step involves determining the potential area of failure associated with the MAF sensor circuit. Begin by turning the vehicle's ignition switch to the off or lock position to ensure safety during the procedure. Disconnect the MAF sensor/IAT sensor 1, specifically the 4P connector, which is responsible for the communication between the sensor and control units. After disconnection, turn the vehicle back to the on mode without starting it to begin testing. Measure the voltage between test points on the 4P connector. Test point 1, female terminal number 2, and test point 2, female terminal number 3. This step is crucial as it will help confirm whether the circuit is supplying proper voltage, crucial for further diagnostics. For the third troubleshooting step, turn the vehicle back to the off position to safely prepare for the next phase of inspection. Jump the SCS serial communication system line using the HDS, which enables you to access deeper diagnostic functionalities. It is important to wait for more than 1 minute after the SCS is jumped. This allows the system to enter the desired mode adequately. Next, disconnect the PCM connector E, ADP, which plays a pivotal role in managing various engine functions. Check continuity between test points on the MAF sensor/IAT sensor 1, 4P connector, and body ground. This step is essential to ascertain whether there is a short in the VCC2 wire leading to the sensor, which could explain the malfunction indicated by DTC P0100. In the fourth troubleshooting step, again focus on checking the continuity of the VCC2 wire, crucial for the MAF sensor's functionality. With the vehicle in the off mode and the necessary connectors disconnected, check the continuity again between test point 1, the MAF sensor terminal number 3, and test point 2, PCM connector E, pin number 77. If continuity is confirmed, this means the VCC2 wire is intact, allowing you to proceed to the next steps in diagnostics. Conversely, if there is no continuity, it indicates an open in the VCC2 wire, necessitating repairs. This could involve inspecting the wiring for physical damage, breaks, or corrosion that might prevent proper signal transmission. Step 5 requires you to check the SG2 wire's continuity, which is essential for the MAF sensor's operation. Ensure the vehicle is still in the off state with the connectors from both the MAF sensor and the PCM disconnected, maintaining safety during the test. Measure the continuity between the female terminal number 2 on the MAF sensor connector and the corresponding connector, number 78, on the PCM. If a continuity check reveals a successful connection, the SG2 wire is functioning correctly, allowing you to look for further diagnostic information related to DTCs or symptoms associated with the malfunction. If there's no continuity, however, it signals a potential issue with either wiring or connections, which will need to be repaired to restore the sensor's function. In the sixth step of troubleshooting, we will examine the FGP wire for any shorts or issues. Begin by ensuring the vehicle is in the off mode to safely perform the disconnect procedure. Once in off, jump the SCS line using the HDS as before, allowing the system to prepare for the analysis. Disconnect the PCM connector E, ADP, and measure the continuity between test points to effectively check for any shorts on the FGP line. This involves checking the female terminal number 1 on the MAF sensor connector and body ground. Confirming continuity here is vital for determining if the FGP wire is shorted or experiencing other issues, which could contribute to the DTC P0100 malfunction. Cue the seventh troubleshooting step. Proceed with continuity testing on the FGP wire again. This time, keep the vehicle in the off state and also ensure that both the MAF sensor and PCM connectors remain disconnected for accurate testing. Measure the continuity between female terminal number 1 on the MAF sensor plug and terminal number 61 on the PCM connector. If continuity is present, the FGP wire is intact, allowing you to progress to further diagnostics or repairs. If there's no continuity, it indicates an open circuit in the FGP wire, requiring repairs to ensure the proper signal flow between the PCM and the MAF sensor, which is crucial for optimal vehicle performance. In the 8th troubleshooting step, we will check for the presence of voltage on the FGP line. Set the ignition to on without starting the engine, allowing the vehicle's electronic systems to power up. Measure the voltage across test points on the FGP line, specifically between female terminal number 1 of the MAF sensor connector and body ground. If there is voltage present, this suggests that the FGP wire has a short to power, indicating a significant issue that must be repaired. If no voltage is observed, this confirms that the FGP wire is functioning properly, allowing you to proceed to check the MAF sensor directly to ensure it is operating correctly. In the final step of troubleshooting for DTC P0100, it is important to conduct a thorough check of the MAF sensor, IAT sensor. Start by turning the vehicle to the off position, then substitute a known good MAF IAT sensor for testing. This will eliminate the possibility that the sensor itself is faulty, which is common when error codes are displayed. Once you have the new sensor, reconnect all the necessary connectors securely to ensure proper functioning. Finally, exit the SCS mode with the HDS and turn the vehicle back to the on position to check for any pending or confirmed DTCs. If DTC P0100 reappears, further investigation into the PCM or other factors may be warranted. If it does not return, the MAF IAT sensor is confirmed to be working correctly. After completing repairs related to DTC P0100, it's essential to verify that the issue has been resolved. Begin this verification process by clearing all diagnostic trouble codes using the HDS. Once you clear the codes, you must monitor the system for any pending or confirmed DTCs to ensure that the repairs were successful. Perform a road test under normal driving conditions to assess the vehicle's performance, ensuring there's no sign of the previous symptoms such as rough idling or poor acceleration. Confirm that the MAF and IAT sensors are providing accurate readings and that the vehicle operates efficiently. By effectively verifying repairs, you ensure the long-term integrity and functionality of the vehicle's engine performance. Preventive maintenance is crucial in avoiding DTC P0100 and related issues. Regular inspection of the MAF sensor should be included in routine vehicle checkups. Keeping electrical connectors clean helps ensure solid connections, preventing data communication failures. Additionally, monitoring the engine's performance for any symptoms indicative of MAF or IAT sensor malfunctions can lead to early detection and repair. Simple practices such as changing air filters routinely can also prevent debris from entering the intake system, ultimately prolonging the life of sensors. By committing to preventive measures, owners can keep their vehicles running smoothly and avoid costly repairs down the line. In summary, DTC P0100 signifies a malfunction in the MAF sensor circuit that negatively impacts engine performance. Understanding the sensor's role and promptly addressing possible causes, such as poor connections or faulty wiring, can simplify the diagnosis. Utilizing a systematic troubleshooting approach ensures that you identify the root cause and rectify the issue effectively. Moreover, preventive maintenance practices will help mitigate future occurrences of this DTC. Being proactive with inspections and maintaining sensor integrity can lead to better vehicle health and performance, ultimately contributing to a smoother and more efficient driving experience. Please like and subscribe to the channel. See you next time.